Lindsay's gonna do number 1 for you.
Yeah, my cousin has it.
Thank you, ma'am. All right, so I did see quite a few of you that had 1.8. We just add the means, 1.1 and 0.7. Lindsay was the only one who interpreted. Makes me sad, really, really sad. She put on a random Friday, we can expect an average of 1.8 cars to be sold or leased in the first hour at work. She also did number 2, but I'm not going to make her come up and do that one. Remember, let's see, I think, no, I don't have it. I have, let's see, where is it? Remember we talked about how we can't just add standard deviations? That if we want to find the standard deviation of t, we have to add the variances and then square root. So that's what you need to do on number 2. Now the thing is, you weren't given the variances, so how do I change those into variances? I square them. So to find the standard deviation of t, I'm going to take the square root of 0.943 squared plus 0.64 squared. .943 squared plus 0.64 squared, oops, 64, if I can type, squared, is 1.298849, and then I'm going to square root that to get the standard deviation of t. So square root my answer, and I get oops, sorry, you guys should have told me I put it where there was glare. 1.14 if I round. And then I'll make it a squiggle equal sign. And how do we interpret standard deviation? What does standard deviation tell us?
Deviations away from the mean.
It tells us how far we are from the mean on average. Z-scores tell us how many standard deviations away. This just tells us how far away from the mean we would be. So on average, the number of cars sold or leased, number of cars sold or leased in the first hour of work on a Friday I don't know why I put on A as one word. That's 2 words, but I connected them. Sorry. Would vary by 1.14 from the mean. Questions? All right, so that was combining discrete random variables. Today we're going to look at combining continuous random variables. Although first we're going to look at another discrete situation. I like this one. You guys don't get the lottery quite as well, I don't think. I had lots of questions about the lottery homework question. Anywho, we're going to look at this one. Nolan's going to read for me.
Most states and Canadian provinces have government-sponsored lotteries. Here is a simple lottery wagered from the Tri-State Pick 3 game that New Hampshire shares with Maine and Vermont. You choose a number.
What state shares with Maine and Vermont?
Sit up. Choose a number 3 digits from 0 to 9. The state chooses a 3-digit winning number at random and pays you $500 if your number is chosen. Because there are 1,000 numbers with 3 digits, you have probability 1 out of 1,000 winnings. Taking X to be the amount your ticket pays you, the probability distribution of X is...
Thank you. That's good. So we have the payoff, meaning you win no money. That's going to happen 999 times out of 1,000, which changed to a decimal is 0.999. And then 1 out of 1,000 times you win $500 because you picked the correct 3-digit number. Yes, ma'am?
Don't some of them say, like, when you buy it, there's, like some of them say, like, 3 out of something, or, like, it changes?
So this is a game that they play over on the East Coast where it's just you pick one 3-digit number. You might be thinking of the, I'm not going to name them right, Mega Millions, and then there's another one where you pick
just
8
like the ones where, like,
or 7 numbers. So that's different because you're picking multiple numbers, and then yes, if you get like 3 out of 8, you get a really small amount of money, where if you get 8 out of 8, you win the jackpot. But this one is just you pick one 3-digit number. If it matches, then you win $500. So we can either win no money or $500. Most of the time we're going to lose because we only have a 1 in 1,000 chance of winning. So the expected value of winning is losing 50 cents. The standard deviation is $15.80. So that's on average how much we vary from the mean. So suppose we buy one pick 3 ticket on each of 2 consecutive days. We want to find the expected value and standard deviation of the total winnings. So we defined X to be the amount the ticket pays you. Oops, sorry, my line got all wonky. So we're going to define a new variable. Let's go with T. They tend to use T for when you're adding, I think because T stands for total. That's my guess. I've never actually known why they choose T. D makes sense for when you're subtracting because it's a difference problem, but never understood T. I think total. So we're going to take our ticket on day 1, so I put a subscript of 1, and we're going to add buying a ticket on day 2. So if we want to find the expected value of t, remember expected value is just a new way to say the mean. So if we want to find the expected value of t, or the mean of t, we're going to take the mean or expected value for the first ticket plus the mean or expected value for the second ticket. They tell us the expected value of winning is actually losing 50 cents. So if we buy 2 tickets in a row, we would expect to lose $1. Questions? Then we're going to also find the standard deviation. So standard deviation of t, like we saw in the warm-up, we can't add the standard deviations. We're going to have to add the variances. So we're going to take the square root of the standard deviation for day 1 squared plus the standard deviation of day 2 squared the standard deviation is 1580. So we're going to take the square root of 1580 squared plus 1580 squared. $15.80 squared plus 1580 squared gives us 499.28, and then we're going to square root. So we get a standard deviation of 22 point, how many decimals am I going to go to? 2, because it's money. So that'd be what, 3.5 if I round. Sorry, my 3 and my decimal ran into each other. Questions? All right, now we're going to look at a different type of combination. So this time, you and a friend decide to play pick 3, but with 2 different strategies. Your friend buys a $1 pick 3 ticket on each of 5 consecutive days. You bet $5 on a single number on your pick 3 ticket. We want to find the mean and standard deviation of the combined winnings for you and your friend. So your friend buys a ticket 5 days in a row. You, on the other hand, say, oh, I'm just going to bet 5 times as much on a single ticket. Now, we shouldn't use t for our new variable because we used it in the one above. I don't really know. What letter do you guys want to use? Not X, because we already have X also.
J.
J. Why J? It's not like your name starts with a J.
I just picked a letter.
Okay. All right, so Seth says let's use J. The letter actually really does not matter, just in case you're curious. That's why I could let him pick any random one. So we're going to define J as the combination for the winnings for you and your friend. So your friend bought 5 tickets on 5 days in a row. So that's like this one up here. Your friend buys a ticket on day 1, on day 2, day 3, day 4, and then day 5. You, on the other hand, bought 1 ticket and bet 5 times as much. So 5 times as much, we would do 5 times x. Questions before we continue? All right, so we want to find the expected value, or the mean, and the standard deviation for our new variable j. Sorry, I didn't mean to turn my paper sideways. So the mean of j is going to come from the mean of your friend on day 1 plus mean on day 2, day 3, day 4, day 5, just like up above. And then you wagered 5 times as much, and so we're multiplying by 5. Does our measure of center, our mean, get affected by multiplication? Yes. So we're going to multiply 5 times the mean of x. Still using the expected value up here. So we have negative 0.5 plus negative 0.5 plus negative 0.5 plus negative 0.5. That's 4, 5. And then the last one is going to be plus 5 times negative 0.5. So how much do you and your friend expect to lose? $5. Do I need to zoom in, Jillian? Questions? All right, so then we're going to do standard deviation. So standard deviation of j is going to come from our standard deviation. I'm going to write this small because I'm running out of room. For the first day squared plus standard deviation of the second day squared, third day squared, fourth day squared. And then what do we do with you? You bought 1 ticket, but wagered 5 times as much. Does standard deviation get affected by multiplication? Yes. So we're going to multiply by 5 and square. So that gives us our 1580s squared 5 times. That's 1, 2, 3, 4, 5. And then for the last one, we're going to have 5 times 1580 first, then square it. Yes. Yeah. Is that far enough? Okay. So, now I'm going to have to put my calculator in the way though, sorry. So I'm going to do 1580 squared 5 times. That's 3, 4, 5. And then the last one, I'm going to do 5 times 1580 in parentheses first, and then square it. So I get 7,489.2. And then the last thing we do is we square root. So I get 86.54. So we would expect to lose $5, but on average we would vary from that by $86.54. Now that we've reminded ourselves about whether the mean and the standard deviation are affected by multiplication, we're going to take that idea and apply it to our continuous variables where we draw the normal curve. Can I move my paper up?
Yes.
May I also zoom out a little? Thanks, Jill. So, it was weird to say so. I said so as my natural, transition. Then I was going to read and I was going to say so far. That was just weird. Sorry. So I had an awkward pause. So far, we have concentrated on finding rules for means and variances of random variables. If a random variable is normally distributed, we can use its mean and standard deviation to compute probabilities, Wesley. An important fact about normal random variables is that any sum or difference of independent normal random variables is normal. So if your first variables you were looking at were normal and you add them together, it's still going to be normal. If you subtract them, still going to be normal. And that's important because then it allows us to draw our normal curve, use our calculator function normal CDF to find the answers. So my example here is that Mr. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with mean 2.17 grams and a standard deviation of 0.08 grams. If Mr. Starnes selects 4 packets at random, what is the probability his tea will taste right? First of all, who likes their tea that sweet?
I do.
I don't put any sugar in my tea. I add lemon. Love. You don't drink tea? What is wrong with you?
Not you.
Sweet tea from any place that isn't probably not.
No,
It's like syrup.
that's disgusting.
Yeah, it is. But also,
I love tea, but I add lemon. Like iced tea, I love iced tea.
Yeah, honey.
No.
there's nothing like a good sweet tea.
Yeah, there is. There's a sour tea.
Yeah.
I like to add lemon. No.
Do you drink lemonade with sugar?
No.
No?
Have you ever
If
had that?
lemonade is too sweet, I won't drink it. I don't like sweet drinks.
You like
I'm
it
weird.
sour.
But you
I love
would you
sweets,
have,
but not sweet
would you
drinks.
have like hot water and like lemon juice? And
Yeah,
like that?
why not?
That's not that bad.
That's like a drink and like lemonade mix.
Yeah, it's called an Arnold Palmer.
Yeah.
No, I don't like those.
I don't like tea.
Sometimes I think I was born on the wrong continent because I like soccer and I like tea. And I feel like I should be over in England or something. Yeah. Like, I love tea. If I got to have tea and cookies every afternoon, oh, I'd be in heaven.
Why don't you then?
Oh, I have tea most nights before bed. I do drink tea for caffeine too.
My sister makes it weird at church. I'll make like myself a tea and then I put like creamer in it.
That's weird.
No, it's not.
All right. Sorry. I got distracted by the amount of sugar that this guy puts in his tea.
And normal.
Hot cocoa.
No. All right, so X is defined as the amount of sugar in a single packet. X is just a single packet. So we're going to define T, if he's picking 4 packets, as X plus X plus X plus X. I don't know how many I said. 4 X's added together. Now, I was a little surprised nobody
Would it not be 4?
told me to simplify this stuff up here. How can we simplify X plus X plus X plus X?
2 to the 4.
No.
X times
4x.
4X. Rather, X to the 4th is X times X times X times X. But wouldn't it be simpler to just multiply one time rather than add 4 things together? That's why I was a little surprised nobody said
Because I
"Hey,
didn't know."
do that up there.
Because this is different math than we've been doing, and you're the statistics teacher.
I am the statistics teacher. All right. So to find the mean, yeah, but that's just algebra. I didn't teach you algebra.
Yeah, but we don't
Your
know.
algebra teacher is very upset right now. So
Algebra.
algebra 2,
You don't know my algebra teacher.
You taught my algebra.
2. Who was your algebra teacher?
You probably Mrs. Baxter.
I do know.
Okay,
All right. So we're going to find the mean of t by doing 4 times the mean of x. How would we find the standard deviation of t?
Might do the standard deviation of t.
Thanks, Seth. We have to take this
Oh,
square
it's the
root.
standard deviation of t, like TEA.
I hadn't put that together, but yeah, sure.
Okay.
I have a question. Wait. Is that 4 times negative 4x or 4 times the mean of?
4 times the mean of x.
Okay, cool. Just a little bit.
How did you fit it in there? I don't know. But I did.
All right. If we know the mean of x, tells us right here, it's 2.17 grams. What's the mean of t? What's 4 times 2.17?
8.68.
Thanks, Lindsay. 8.68. And the standard deviation of x is 0.08. So we're going to take 0.08 times 4, square it, then square root it. What do we get?
But you did.
I already did it in my head.
Oh,
So
wow.
What is it?
Do it on your calculator, Nolan.
Well, you already did it.
4 times 0.08.
You cannot get that in your head.
That's 0.32, then I square it something, and when I square root it, I get 0.32 again.
This is the power of reading.
I guess so, yeah.
I don't know what tea she's been drinking.
I don't put sugar in it to kill my brain cells.
You just drink straight.
Kill your
Wait,
Sugar is for keep your brain cells alive.
I don't put sugar in my tea, no. What? What did you say?
I would get like tea with stuff in it, but not like
My favorite is green
Is
tea.
gross.
Lucky my mom drinks that.
All right.
It tastes like wet leaves. Why do you like that?
yeah. I just drink. I like.
You You guys are too caught up on the fact that I don't like sugar in my tea.
Very specific.
It's just wet leaves at that point.
No.
That's gross. It's just like
Then you put peanut butter in there?
Gross. No.
That's gross. I should probably want to taste that. You should try it.
Peanut oil.
Yeah.
A few drops of that. Peanut oil. But Whittle, here's a real question. Have you ever had a peanut oil and mayonnaise sandwich?
No, gross.
My grandma one time made us eat peanut butter and pickle sandwich. She's like, yeah, we used to have it.
And you did it?
No, I started crying. And then mayonnaise, and banana. And I was like, yes,
Oh my gosh.
All right. Quiet back down. So, now that I know the mean of 4 sugar packets, the standard deviation of 4 sugar packets, I can draw my normal curve. It's got a mean at 8.68, standard deviation of 0.32. We want to find the probability that those 4 sugar packets have between 8.5 and 9 grams of sugar so that Mr. Starnes thinks his tea tastes right. So 8.5, that's in between 8.36 and 8.68, probably a little closer to 8.68, so we'll say there-ish. I can't draw a straight line. And I'm going to label it 8.5. And then 9 is the upper bound. That happens to be one of our hash marks we labeled. And then we're looking for the area in between those two. What's our calculator function? Normal CDF. What's the lower bound, Wesley?
What?
Shh. I don't care if you choose not to learn, but she needs to learn. So stop distracting her. What's the lower bound? Thank you. Upper bound?
9.
Mean?
8.6.
And standard deviation. And then if you have an older calculator, remember you have to type the commas in between. Otherwise, it will prompt you. Everybody okay if I cover up part of the stuff? So second bars, number 2 is how we get to normal CDF. 8.5, 9, 8.68, and 0.32. So we get 0.5545 when I round. And the other part that we have to do is interpret what this means. So what information did we just find?
Area between 8.5 and 9.
In the context of the word
chance
problem.
That he gets the perfect amount of
The probability that his tea tastes correct when he chooses 4 random packets, right?
yeah.
So again, you could probably word it better than me, but something like Mr. Starnes' tea will taste correct, will taste right, is the word that we used before. 55.45% of the time. When he uses 4 packets of sugar. Oh man, ran out of room. Uses 4 packets of sugar. Ugh.
Wouldn't it
disgusting.
be a normal curve because of the chance of there being an empty packet because they just didn't put sugar in? Wouldn't it get?
Why would there be an empty packet?
Because like the factory that makes the packets of sugar, if like one of the packets accidentally doesn't piece sugar in it, that would be a giant.
Well,
outlier.
wouldn't you just pick another packet then?
Yeah, but like if you were to randomly pick,
You like
the
to
actually,
you like to really overanalyze my examples, Seth. All right,
I'm right.
sure.
You're right.
It would be very skewed.
But then
Maybe
you're
they
right.
took into account that they're,
It doesn't say replace empty packet.
or maybe they took into account those once in a random while the empty packets, and it's included in the mean.
Okay.
Yeah. All right. Can I flip? Any questions? So we just added
Is it the same?
continuous random variables. Now we're going to subtract some. This is one of my favorite examples.
You said about the first one.
I like math, Nolan. Okay, stop it. Scores on the ACT follow approximately normal distributions. Females have an average ACT score of 19.6 with a standard deviation of 2.3. Males have an average ACT score of 9.2 with a standard deviation of 4.1. Suppose that we randomly select a female and then independently randomly select a male and record both ACT scores. What is the probability that the female scored at least 2 points higher than the male? So, few things we need to do first. We're going to define our variables. So we're going to let f equal what? Male or female? Female. Okay, good. That way we can keep it straight. F is going to be the female scores. Female ACT scores. And it tells us that females have an average of 19.6, standard deviation of 2.3. So I'm going to write those down below. And then M is going to be the male ACT scores, which it tells us up above they have an average 19.2, standard deviation of 4. 19.2, standard deviation 4.1. D is going to be the difference. Remember, I told you I know why they use D. D stands for difference, so we're doing a subtraction problem. And subtraction is not commutative, so we need to think through whether we want to do female minus male or male minus female. Thank you. Excuse me. So the question that we want to answer is, what is the probability that the female scored at least 2 points higher than the male? Would it make more sense to do female minus male or male minus female, and why? Why?
Is the chance that we're looking for?
So Seth says female minus male, and I would agree. We want to see what's the probability the female scores higher. If you did male minus female, you could also find the answer, just it would be you're working with negative numbers. I personally like to work in positive numbers. So if I do female minus male, and I'm just going to pick two random numbers to show this point more tangibly, not so abstract. Let's say the female got a 23 and the male got a 21. When I subtract, I'm working with positive numbers. If I do it the other way, male minus female, and the male got a 21 and the female got a 23, I can still find the probability the female gets a score 2 points or higher. It just would look funny because I'd be working in the negatives, but I could still do it. I personally am like Seth, and I would do female minus male. But you still could do it if you mixed up and did male minus female. We're going to do female minus male though. So how do I find the mean of D? Can I subtract my means? Yes. So I'm going to take the mean of the females minus the mean of the males to find the mean of my difference. So 19.6 minus 19.2, which is 0.4. Sorry. How do I find the standard deviation when I'm subtracting? Remember, this is almost. It's a weird one. We square them, we add them, and then we square root them. No matter whether I'm adding or subtracting, I always add my variances. So I'm going to take the standard deviation for the females, square it, and I'm going to add that to the standard deviation of the males squared, and then square root my answer. So 2.3 squared plus 4.1 squared, and then square root that, and I get 4.7 for the standard deviation of my difference. Everybody good so far? All right, and then we want to find the probability that the difference is greater than or equal to 2. So we're going to draw our normal curve, shade the correct area, and do the calculator stuff. And then we're going to interpret. Ugh, that was a bad curve, but we'll go with it. 0.4, 4.7, maybe. I can draw, so here's 0.4. When I add 4.7, that puts me at 5.1, 9.8, 13, 14.5. Did I do those right? I did mental math. I hope somebody's double checking me. If I subtract 4.7, that'd be negative 4.3. That'd be 5, negative 9, negative 13.7. Did somebody double check? Okay, good. I was pretty sure on the adding, but the subtraction, I'm bad at subtraction. You remember those times things you used to do in elementary school?
Like get as many.
I was amazing at multiplying, dividing, but I struggled with subtraction. My brain just, I don't know why. All right, so we want to find the probability the difference is greater than or equal to 2. So 2 is somewhere between 0.4 and 0.5. Maybe a little closer to 0.4. I don't know. We'll say it's there-ish. And greater than 2 would be over here. So we're looking for that area. Normal CDF. What's our lower bound? What's the upper bound?
1.5.
big number, which we use 1E99, like Annika said, average 0.4, standard deviation 4.7.
Wait, why is it two?
I'm sorry, I didn't hear you.
Why is it two right
Because we want to find the probability females scored at least 2 points higher. So in math terms, the difference, so the subtraction between the two, is greater than or equal to 2. Did that clarify? Or were you asking about this too?
there? No, I was asking about the one on mine.
This one?
Yeah.
Because I'm interested in finding that the difference is greater than or equal to 2. So that's 0.4, that's 5.1, so 2 is somewhere in there. I don't know exactly where, so I just labeled it as 2. Second bars, number 2. 2 is the lower bound. Remember to get your E, it's the second comma. So comma is right above the 7. And then 99, the mean is 0.4, standard deviation 4.7. So 0.3668 when I round. And how would we interpret that?
There's a 36.66% chance that a randomly chosen female will have a CT score 2 points or higher than a randomly chosen male.
I really do apologize. I'm sure there's a way to be more concise, but I'm not good with words. Yes, I'm sorry. Questions? Can I move it up? I take the silence. Oops, I wanted to zoom in more, not zoom out. Sorry. All right. Leona and Fred are friendly competitors in high school. Both are about to take the ACT college entrance examination. They agree that if one of them scores 5 or more points better than the other, the loser will buy the winner a pizza. Suppose that, in fact, Fred and Leona have, that should say equal, sorry, my math brain just typed equation, equal ability, so that each score varies normally with a mean of 24 and a standard deviation of 2. The variation is due to luck and guessing and the accident of the specific questions to the students. The two scores are independent. what's the probability that the scores differ by 5 or more points in either direction? So that should say equal ability. Now the change here is that it's 5 or more points in either direction. So we're actually going to be looking at a two-sided problem. So we're going to have two shaded areas on our normal curve. But before we get there, we need to define some variables. So I'm going to use L for Leona. So Leona is an L. The mean for Leona and the standard deviation for Leona tells us that since they both have equal ability, each score varies normally with mean of 24 and a standard deviation of 2. I'm going to use F for Fred. So the mean for Fred is also 24, and the standard deviation for Fred is also 2. Now it tells us we want to find the probability that the scores differ, so we are working with the subtraction problem. Now, does it matter if I do Leona minus Fred or Fred minus Leona? No, because we're looking at 5 or more points in either direction. So, I don't know, you want to do Leona minus Fred just so that it's in the same order that I wrote L and F. So, the mean for our difference, 24 minus 24 is 0. Standard deviation for our difference is going to be the square root of 2 squared plus 2 squared, which is the square root of 8.
Almost 3.
I should be able to do this. 2.828. You say it's easy. This is from the guy who can't even type it in his calculator.
I said it's about.
You did good. I was picking on Nolan. He told me it was easy and I should be able to do it and I had no problem. But he wouldn't even type it in his calculator. All right. Everybody good with the mean and the standard deviation? Okay. So now we draw our curve just like we usually would. It is normal with a mean of 0, standard deviation of 2.828. That's 0. I don't know why I went to so many decimals on the standard deviation. That's going to make it hard to add. Oof. I didn't think that one through. This is 2.828.
Don't we have to consider that you can get an ACT score of like 32?
No.
No.
So 2.828, this is 5.656, and then 8.484. And then it should be the same, just negative on the other side. Are we good? So we want to find the probability that the scores differ by 5 or more in either direction. So 5 over here is going to be, we'll say there-ish.
Yes.
Yeah, sorry, my brain is
It's okay.
right there-ish. You're right. I'm sorry. See, this is why I ask you guys to check when I do mental math, because I do make mistakes. So there, and then -5 would be there-ish. Now, what's a cool fact about normal curves? It's symmetric. So if I find this area, I can just double it. Or if I find that area, I can just double it. And it'll give me the area for both. So which area do you want to find?
The right.
The right. I like that too. So let's find the area of the right. Our lower bound is 5. Upper bound is a big number. Mean is 0. Standard deviation is 2.828. And then once we have that, we're going to multiply it by 2 because of the symmetry of our normal curve. Second vars, number
You also just
2.
do 1 minus the middle part.
Yeah, you could do that, yes. Alright, so I get 0.0385 when I put that in normal CDF, and then I'm going to multiply by 2 to get the area of both tails. So 0.0771 when I round. So what does our answer tell us? And if there's a difference of 5 or more points, what's going to happen? One of them buys pizza. So there's a 7.71% chance that somebody buys somebody pizza? Oops, might help if my pen's open, huh? Am I off the screen? Well, wasn't off the screen, but the silly paper was in the way. Are there questions? All right, so before you pack up and all that, I'm a bit surprised that only one person has come to me and been like, are you sure you did this right? Your test for this unit is at the beginning of next quarter. There was absolutely no way I could fit it into this quarter without making you test on the all block day, and we know my tests aren't short enough to fit them on an all block day. So I decided to put the work day in there, which is next week for you guys. I can't remember which day exactly. The 17th. That's your retake deadline for Unit 5. If you're not happy with your Unit 5 score. If you check your Canvas grade and you're happy with the overall grade, that's your overall grade for third quarter, and you can just be like, yes, I'm done for this quarter with this class. Second quarter. My brain is not working well today. I'm sorry.
This test is going to count for a third quarter.
Yes, this test goes on third quarter because grades will be due before that. But next Monday is your retake deadline for Unit 5. Well, and I will offer you time in class to retake. Otherwise, you come in on your own.
Unit 5 was
outside
the
class.
last test, right?
Probability.